Go!
Hello everyone, welcome to Practical GCP. Today's topic is about event-driven BigQuery consumers, which means rather than using schedules to schedule downstream consumer jobs that consume data from BigQuery, we would track BigQuery table updates and turn them into events. So to make this a bit easier to understand where exactly we're talking about, let's start with a problem that we look at. So this is probably what you are very familiar with typically, especially with data coming into BigQuery via some kind of ingestion pipelines. You would have daily ones, near real-time ones, and also the unpredictable manual uploads for reference data. So the data ingestion ones that are coming from daily, it's not possible to not have problems, right? So every now and then you have the data late, even by an hour or by like 2 hours. Then what you typically have to do is to hang on a second, my schedule no longer works. I have to rerun something with the data engineering team and update something. Then downstream consumers are affected, right? You have other ones where typically data coming from event-driven systems such as Stream, Google Data Streams, or Fivetran, right? So these are capable of streaming data from relational databases or traditional databases from on-prem systems or other networks, and then these will typically come in near real time. But these things also have all peaks, right? If you need to process the data in near real time using schedules, then you have a problem here as well, because there's many hours during the day you may not have data at all. So the last one is probably the most tricky one, because very often you also have unpredictable file uploads. So when these files are uploaded, they get loaded into BigQuery, but then you may never know when they actually arrive in BigQuery. So in downstream systems, right, you typically have, the top one is probably the most standard one in most companies, where you have scheduled consumers that you run some queries, get data from BigQuery, model some data, put it into some other models, which typically these are DBT jobs or Cloud Composer jobs. You turn these into kind of refined models, and then you consume them in dashboard. But even with these use cases, if your data is late, there could be very clunky processes to actually even get data into your dashboards. But for more advanced use cases, this becomes more troublesome, such as if you want to have a process to update your storage engines, right? That could be in Cloud Data Store to serve like API backends for other applications, or you have a downstream subscriber based on some kind of events trigger using Cloud Run, or simply many different use cases that use GKE to consume data based on events. So these become very complicated to design, especially where you're trying to process the data not daily, not hourly, probably near real time in some of these use cases as the data come in. Let's look at what if we can actually track the changes, right? If you think about what if we can track the changes rather than use the schedules, if we have some kind of, if we can use BigQuery to generate some kind of events, right? Can we do that? We'll see. And then these events, then we can have event listener, right? Then we can listen to whatever that's actually happening in BigQuery and then use those events to trigger what we need to do downstream. There's two very specific information schemas. One of the previous sessions, I have already talked about the information schema tables that created for BigQuery, which has many useful information that are tracked as metadata, right? So there's two very specific ones in this place that I found that seems very useful for our use case. One is the streaming timelines. The other one is partitions. So let's have a look at what they actually do. But one thing, keep in mind that I put one thing in here is about using where the idea is to try to use metadata to track data, but not use data to track data, which not only is easier because the data is typically smaller, and then in a more is better way, in a unified way, right? And then also it's you don't actually have to care what the data looks like, but also just when something has changed. So let's have a look at these two in a little bit more detail. The streaming timeline view, if we actually jump to some of the details on what we actually get in here. So this is a table kind of created or views created by BigQuery to give you information such as, when the streaming buffer, right, or the streaming data that isn't actually stored in the permanent storage yet, right? Or typically when you have streaming inserts, then this data actually comes into a streamed buffer, not quite the same as a normal partition. So these needs to be tracked separately, and this is the view that Google provided to actually give you this ability to do that. It has a number of useful things, such as project ID, datasite ID, table ID, which gives you a unique identifier of a specific table in a project. Then you have the start timestamp. If you pay attention to what it actually says here, it basically says everything that is successful, and then in 1 minute interval as a row for a particular table, which is extremely useful. We'll look into a bit more into the details after we explore the other one. So the other one is the information schema partitions. This is currently in preview, but it also contains very useful information. If you look at what's going on here, so what we have here is a bunch of things, but also contains table catalog, which is the project ID in this case, the table schema, which is the dataset name, and the table name, which is the table ID. It has a number of other informations, but you also see it allows you to track the last modified time of a particular table. Let's have a look into the details of these two specific views. So first of all, if you look at the streaming one, let me just run this again. I prepared kind of two tables, one with partition, one without partition. I'll explain later on why. And this one, you can see I've actually inserted some data into the one that by ingestion time, right, in this particular case. So if you look at the data here, what typically I have here is you've got a unified identifier of a table. You've got a start timestamp, but if you look at this, right, this is quite interesting. You've got if you look at this, these ones are actually quite close together. The start timestamp, you have the 29s, 37s, 12, right? But some of these are very close to each other. You've got 57, 58, 59. So these are the 1 minute intervals in the description it was talking about. But also, very importantly, if you actually do not have data in the streams, it will not give you a row in the 1 minute interval. This is what I was talking about, right? So if you need to process your data every single minute, this becomes very useful. Let's have a look at the other one. Let me run this again. This is different. This is the partitions, right, of a specific table. Now you see why I've actually included both tables, because this one actually works with partition tables and non-partition tables. So the non-partition tables basically simply has a partition ID of null. The partition tables will have the partition ID in there. The things we care most about is the last modified time in this particular case, right? If you look at last modified time, then this is something that we can use or utilize to track when something has changed. So I've got 1912, right? It's a little bit earlier than today UTC. So let me run a script that you can see that this is actually changing. So this is some scripts. I'll come back to this later on when I explain the code as well. But now what I'm trying to do is to simulate the change of the streaming buffer and also the partitions, right? So partition using a BigQuery load drop. Now if I look at it again, you can see that immediately the last modified time has been changed to right now on both tables, because I've just basically loaded data into both. So this allows us to track data. So come back to what I was talking about earlier with events. So this is very important, that if we can generate some kind of events and then we can listen to those events, now we have a possibility to do that. Okay, let's look at the design concept here. So the way I came up with to solve this problem is to have a per minute schedule in the middle, utilizing those two information schema views, right? So what this per minute schedule means, and why is per minute, is because most schedulers, if you use the cloud scheduler on Google Cloud, or if you use Cloud Composer, whatever you use, typically is based on Chrome. You can't actually go lower than a minute in majority of the use cases, and also 1 minute if you try and run any schedules less frequent than that, it doesn't really make a lot of sense, right? So for 1 minute schedule, what we're trying to do is we try to identify and fetch the deltas. Then we send those events into a pub subtopic, which can then be consumed by other subscribers later on, right? So that can be Cloud Run, can be GKE, can be many other things. So basically what those event subscribers will do is, for example, I'll give you a number of use cases. One is manual upload, right? So when the manual upload got triggered, we have one event fired up in here, and then the Cloud Run or GKE cluster will say, oh, I've now found there's one event saying this table has been updated because someone manually uploaded data in there. So you can immediately trigger a rebuild of your download data source, right? So because you have identified that table has a change, then you can at that point rebuild your downstream data source that could be serving other reports or other things, rather than try to do it every day or every hour, which is very unpredictable and you don't know when it's going to come, right? There will be other use cases such as very useful one, which is when there's delays, right? So if you actually use events to drive your downstream table rebuild or the hourly rebuild or whatever, if this is late, right, simply you would not trigger the downstream process. You wait for the event to come in, which could be 2 hours late, which could be 5 minutes late. At that point, you trigger your BigQuery query to build your downstream process for your data models or for your storage engines, and then at that point, it can be immediately triggered with your most up-to-date data, right? That's another use case. So if you think about the reason I have this 1 minute schedule is because this 1 minute schedule not only will cover one specific use case, it will look for all of the all of the tables you can, because in this, if you go back a little bit, you can see that here you can specify a data set in here, and in the other one you can actually specify a regions, right? There's a number of ways to query the information schema tables, which means you can include many tables at once when you're tracking the deltas, which subsequently means you can track everything in there and send events for everything and have a centralized process here to manage all of the things that have been changed across many BigQuery tables. Then your event subscribers simply filter on the things you're interested in, which can be done on the pub subscribers, and then you trigger the things basically in your own domain, right? Regardless of what everything else changed. The one thing I want to specifically talk about is the checkpointing management. So the reason I want to talk about checkpointing is that if you think about like every single minute schedule, right, you might just say, oh, I've just got a scheduler, I use the time right now, and now I pick a minute of changed events, and then I'll just send those, whatever I pick up as events, right, into the downstream systems. Well, not that simple. So checkpointing, it's not as simple as you start tracking, every minute. Let's say this one, you run the first part, your start and end, and then the second one, you run your start and end, right? But what often can happen when you run any kind of computer systems is your schedule can be late. Let's say if you use the Cloud Composer scheduler or if you use Cloud Scheduler, these can all be under maintenance, or if there's an outage of Google Cloud. What you shouldn't do is to just ignore that, right? If you ignore it, you would lose data because the data is identified as a gap. So what you have to do is to make sure if you tracked, this thing in your first run, however long the gap is, let's say the scheduler you use is down for an hour, right? For a whole hour. And then by the time you come back in the hour, your actually starting point is here. What you shouldn't use is this time, right? You can't track all of the deltas from this time onwards because between the end and the start, which is the gap, there's also events, there's data in there, right? Because BigQuery hasn't gone down and all of these events that have been tracked is still being tracked. If you do from start to end here, and then start to end here, then what you're going to lose is the gap. That's the data you're losing. But if you practice checkpointing by storing this, right, whichever data timestamp you used to track what you've tracked before, right, regardless of what's happening and when you run the scheduler again, you're always going to track from this point to your new end, right, which is this bit, and that is correct. So this is checkpointing. When I later on come back to the code, I'll explain a bit more of exactly what that means when running the queries. Okay, let's see how it works. this is the code example I've pushed into GitHub. Let's have a look at the structure of this repository. So first of all, you've got the data producer. I ran it earlier already, you saw. And this data producer is about sending data, just some dummy data, right, into those tables I've demonstrated earlier to trigger the kind of events we want to see, right, in the information schema views. And then you've got the partition events producer. This one is using the partition view to track events. And the second one is the stream events producer to use the stream view to track events. So now you've got two folders. One is the checkpoints. This is the thing I talked about earlier. And then you've got output, which is later on I will show you what the event looks like. I was trying to unify these two, the events produced by both, and then it can have a unified interface for whatever consumers that when they decide to use either kind of events, right? So let's have a look at the partition events producer first in the source code. So if you look at this, what I'm doing here is I've defined where I want to keep the checkpoint, right? So keep in mind, this is just for the purpose of this this video. In reality, you very unlikely want to keep it in a file system, right? It's very difficult to retrieve it using different schedulers and like instances. It's very difficult for the distributed workload. So that's why I put cloud data store in there, which is something you can use a key and to track your checkpoint in a distributed locations, right? It doesn't matter where you run this code, and then you can always retrieve your checkpoint reliably. I've generated the time of now, which is UTC, right? Then what I'll do is in this block, I've tried to load the checkpointing information from the file system, right? If it has, so I'll try to load, but if the file doesn't exist, it means it's the first time I'm running it, right? And if it doesn't have that thing, and then I wouldn't have any checkpointing. In that case, what I'll do, I will set it to right now. So that's kind of the first time processing, right? You process from that time onwards, and then you start generating events. Obviously, you can't just go back to all historical events, right? That's not what the system is for. You start from right now if there's nothing, and then if there's something's been recorded, then basically you retrieve it in the next run, right? So this script typically is the one that gets scheduled every minute. This is where it gets interesting. This whole query is what I've designed to track the event delta. There's a few important things I want to show you here. One is to create a unified interface. You've got project ID, data side ID, table ID, and whatever, right? Then what I'm trying to do is to create the event type, so you know what kind of events it's generated from, and then I'm using the last modified time and the last to the minimum or maximum last unified time to actually give you more information in events of the minimum maximum. Because what I'm trying to do is, even you have a gap, right? What I don't want to send you is a lot of events. Because if you have a gap of, let's say, 1 hour, what you typically want to do with those events is to process the whole gap, right? So to process the whole gap, what you don't want to do is to have, let's say, 6-10 different kind of events you generate. You have to do all this complicated thing in the consumers. What you want to do is to when did it start, right? If there was a gap, and when did it finish. So that's the minimum maximum. So you can use those information to know when was the first time the table was changed, and when was the last time the table was changed with this modified kind of information. And then I have a from timestamp and a to timestamp. This is basically indicating using the checkpointing to decide what data it has processed, right? So what I'm trying to do to keep it simple is to always have the from as the previous checkpoint. So it doesn't matter how long the gap is, you always have the checkpointing from the previous part, right? And then to is always right now. There's not much point in trying to process, if you're already 1 hour lapsed, right? You don't want to go back to, at 59 minutes and just do that 1 minute. You want to just process the whole thing until right now, right? When you run the script. And then what that means is right now would become your new checkpoint. And that's why later on you can see here, I've updated the partition info with the checkpoint of time right now. So that's very important, because after you process this whole thing, your checkpoint is now written into the disk, right, into the storage. The one last piece of information that is useful is this last modified time filter. So what I always want to do is to process everything, right? Everything that is greater than this, this checkpoint, because previously it has included, right? It has processed everything in the previous run, right? Now I just want to include everything that is greater than this point from the previous checkpoint. So this would give me everything from the last bit where it's got processed into right now every time it runs. So this is kind of the idea how it works. And if you look at the other one, which is the stream-based events, this one very similar concept, and here is also very similar as well. But one thing I have done to keep it simple for the time being is to generate a checkpoint minus 10 minutes kind of checkpoint. The reason I do this is because if we go back to the BigQuery one and run this again. So if you remember a few minutes ago, I ran the script, right, with the data producer to try to generate another event. But what actually happened was this table typically have about, I think, around 5 minutes delay, because it's something that gets aggregated, right, into a window. So this table, this view, doesn't actually give you the most up-to-date information. It's unlike the partition one, right? The partition one, it gets updated instantly, but this one doesn't. This one takes about 5 minutes-ish for it to be updated. So what I've done is I've created a 10-minute delay for this to include all of the processing. And if you look at the code again, all I'm saying is process the checkpoint minus 10 minutes, right? Anything greater than that. But if this runs every 1 minute, and it's going to include 9 minutes worth of duplicates, right? Every time it runs, it's going to have 9 minutes worth of duplicates. And that is from design perspective of this solution, that's okay, because I would rather I have duplicates than losing data, right? What you can do later on is you can actually make this a little bit more sophisticated, maybe including 10 minutes or even 20 minutes, because I'm not sure exactly how often this table gets updated, this view gets updated with the streaming timeline of the project. What you can do is to include a bit more, and in this processing, to create some kind of hash, right, based on the event rows. And then you can track all of these at individual table level to give you a much better view of events rather than including all of these duplicates. So this one, yeah, it will include duplicates, but it's not a big issue because you can actually do this in the downstream processing as well, right? So if you see duplicates in your downstream processing, because you have the start and the minimum and maximum processing time, if in your downstream subscriber you notice they're the same, you can simply ignore the event, right? But I do not want to lose these events because this thing has a out of date. It hasn't been populated yet, right? So that's the code examples. Let's sum this up and then also discuss some next steps, how to make this solution production ready and easier to use. So we've discussed about the event producers. We talked about a little bit more having more granular control of the checkpoint tracking, because it's right now, especially for the stream-based solutions, it generates quite a lot of duplicates, like 9 per every run, right? 9 duplicates instead of just having the one you need. But again, like I mentioned, you could use that solution simply for simplicity to filter those out in the consumer process, or you can use checkpointing in a more sophisticated way to make sure you track the checkpointing on the individual identifier, which is a table level, and then you can see exactly how to deduplicate the events you're going to send. The checkpointing process using a local file system isn't very flexible. It's not going to allow you to run your code in the serverless processing. Let's say if you use Cloud Run or Cloud Function to basically do your event producer process every minute, then you can't use your local file system because that's just there isn't one, right? So you don't want to, because it's all serverless. And then in that case, you can use something like a Cloud Data Store to reliably track your checkpointing in that system. Obviously, the events isn't useful unless you produce them into a proper event broker that you can subscribe using other systems, and this is typically you use Cloud Pub for this kind of purpose. So let's also have a look at the problem we solved here. So we have this solution now is going to solve typically 3 problems, and this is the 3 problem statements we described at the very beginning of the solution. And one, if you have delayed daily, hourly ingestions, these are automatically processed when the data arrives on a later time, right? So it's not going to be, you have to retry something. You don't have to do something like that because it will automatically be triggered when the event arrives. The near real-time changes, and then now tracked near real time without doing useless work at off-peak times. So if you have, your data wave like this, you have like a peak, off-peak, peak, off-peak, right? Then in off-peak time, you typically just don't have something, right? Especially with some event-driven system, this becomes very problematic. If you try to do near real-time processing with that many events generated, you just don't, you don't have to deal with that anymore. You just use basically on whenever this event gets generated, and then you can consume them later on at exactly the right times. And then finally, the manual upload. This is probably one of the most useful things, is when something gets uploaded manually by somebody into BigQuery table. Now, because it has been uploaded exactly at that time, when you generate events, then you can trigger downstream systems to basically update your process at that exact time. Okay. So I think that's the end of the session. So hopefully you found it useful. There are obviously a lot more you can develop with this system. I have not proved it to be on production ready yet. This is the concept recently I was thinking about and came up with. So please let me know how you feel about this, and then what do you think about this, using this solution to track data in BigQuery? Because at the end of the day, not every company or every place you're going to have all of your data in the events, right? There's lots of data would typically sit in an analytical database or relational database that ended up in BigQuery that is not able to give you natural events processing capabilities, right? But with this kind of approach, I believe it will give you a lot more capabilities, especially for near real-time processing of data in downstream system, in the downstream consumers in here that process those events. Okay, thank you very much, and I'll see you next time. Bye.
Go out!